Hello, it's Mark from Embedded Pro, and this is a quick tutorial on how to use the energy measurement feature in the MCU-LINK-PRO debug probe from NXP. It needs to use the CMSIS-DAP firmware, so make sure that you have the CMSIS-DAP firmware installed. The MCU-LINK-PRO can measure voltage, current, and power during a debug session, and that's very helpful when I'm developing code that runs in low power modes. In this tutorial, I'll demonstrate current measurement. To use the power measurement feature, we need to hook up the current sensing cable to a convenient current measurement header on the target board. I'm using the LPC55S16 EVK, and there's a convenient header, JP20, where I can measure the current flowing into the MCU VDD rail in the power tree. You can see the header here in the schematic. So first I connect the sense cable onto the connector J9 on the MCU-LINK-PRO with the yellow wire on pin 1. 3 jumpers on the MCU-LINK-PRO configure the current range for the probe, either low range, 0 to 50 milliamps, or high range, 0 to 350 milliamps, with J16, J17 and J18 in positions 1 to 2. I'm using the LPC55S16 EVK and therefore the low range, so the jumpers are in positions 2 to 3. Then, on the LPC55S16 EVK, I connect the feed yellow wire onto pin 1 of JP20 and the orange return wire onto JP20 pin 2. There's also a black ground wire, and I'm connecting this to a nearby ground. It's pin 2 of the ISP header JS3. And of course, I have the MCU-LINK-PRO connected to my LPC55S16 EVK using the 10-way serial wire debug ribbon cable. I'm now in MCUXpresso IDE version 11.4.1, and I have the multi-peripherals test project from the LPCXpresso 55S16 SDK open already in a debug session. And now I can add the energy measurement view. I do this from the analysis menu and select energy measurement. When I do this, a new view opens over here. And next I have to tell the energy measurement tool about the debug probe context to use. I just select Identify Probe and complete the dialog. After selecting the probe, I can configure the energy measurement that I want to perform, and today I'll be selecting Target Current. And lastly, simply to confirm that the probe is configured, I can read the target voltage with Read from Target button. I can see that the target is powered and is measuring about 3.3 volts. I can start current measurements using this Resume button, and now measurements begin when I start code execution with the F8 Resume button. Now we can see that board currents are collected and displayed in this chart, and they're oscillating around 2.8 milliamps. The variation in current is being driven by the current flowing into the green LED on the target board from the LPC55S16 microcontroller. If I now push the switch labelled User on the target board, the green LED becomes permanently on. And we can see this in the current display on the graph. And when releasing the button, the current goes back to oscillating around 2.8 milliamps as we saw before. Well, as a quick and easy test, let me replace the energy meter probe with my digital multimeter. I've stopped the debug session and disconnected the MCU-LINK-PRO from USB on the host. And now I'm connecting up the multimeter. Now I power up the MCU-LINK-PRO. It supplies power to the LPC55S16 EVK, and the measured current is again around 2.8 milliamps. That agrees with the current measured by the MCU-LINK-PRO. All is good. I'll be investigating further advanced features of the MCU-LINK-PRO over the coming weeks. Come back regularly for more videos. And don't forget to share and like this video and subscribe to my YouTube channel. I'll see you soon. Goodbye.